We're live again. Welcome, everybody.
Hello.
It's usual suspects. Scott is here with me, answering any questions you might have. So start typing questions. First come, first served. And before we start, first of all, apologies from my side. I had to cancel it last week without telling anybody. It was the last moment. It happens. Now we are back. We are here. And let's see if anybody has any question. You know the drill. If you've been here before, you know the drill. If you don't, let me spit it out for you very quickly. We haven't prepared any. We just answer your questions. That's all we do. We're lazy folks, lazy people. No preparation in advance. Okay, so let's see. Is there any alternative to Cargo? We can't use it due to the requirements of one namespace per app and support for only local Argo CD app sync. I'm assuming that this is a question specifically for Argo CD. There are a bunch of alternatives. There is one from CodeFresh. There is Argo CD itself, actually. I forgot the name. Do you remember the name, Scott, by any chance?
You're asking me an Argo question?
I don't know why I'm doing that. I just now... You're going to go into rage mode now. Sorry for that. Ignore my question, Scott. I don't remember, but Argo CD has itself inside the project has a solution, but I don't remember the name. What happened? You might want to check that one out.
Yeah, I'd say the other alternative is YQ and GitHub Actions.
I was trying to be nice. To me, that's still a solution. That's why I don't know those that well, because I don't see what's wrong with YQ. It's awesome.
I think that Cargo, I think that this is the natural direction that GitOps is going to go in and needs to go into to figure out the promotion story better. But I don't think that Cargo is at any level the correct decision. I think that it is way too limiting. It may just be very immature still. When I tested it initially, and I was willing to because I care about this area, even though it deals with Argo CD, I was willing to. But one of my biggest issues with it is that the coupling to a specific tool is a major issue in my mind. And the fact that Cargo ties itself to Argo CD automatically cancels it out in my mind, because a good tool in the ecosystem of Kubernetes works with other tools in the Kubernetes ecosystem and does not tie itself to one implementation of something that there are many implementations of.
In theory,
and it can work better with. It can work better with. It's like Tecton does not tie itself to anything. Argo Workflows doesn't tie itself to anything. Argo Workflows works really well together with Argo CD, and there's nice coexistence between the two, but there is absolutely no reason you can't use Argo Workflows together with Flux if you preferred Argo Workflows over Tecton, let's say, and wanted to run Kubernetes CI, right? And that's my issue with Cargo.
I would even go further and say, I'm not sure whether those tools even should tie specifically to GitOps tools, right? Because basically the goal of those tools is to push changes to Git, right? After specific events happened. Human review, successful deployment to staging environment, blah, blah, blah. Whatever the conditions are. When conditions are met, those tools modify or push a change to Git, right? And now, theoretically, if I'm going to deploy that change by triggering GitHub Actions that will execute control apply, so be it. Why not?
Right.
Not that you should be doing that, just to be clear, but...
And I'm not sure that it should go that far. I think like one of the best examples in the ecosystem is Carpenter, I think. Carpenter was built by AWS. Carpenter initially only worked on AWS. But when they built Carpenter, they built it with a plugin mechanism, and there was only one plugin. That plugin was AWS. When it went out and it moved to Kubernetes SIGs, immediately Azure started working on a provider, and then there's the Azure provider for Carpenter. And now there's a third-party one for Google as well, because Google haven't built one, so someone else built one that works against GCP as well that's also apparently very good. There's one being worked on for Cluster API as well, right? So building a tool with a plugin mechanism, I don't care if the only tool, if they're just Argo folks, the people that work on Cargo, which is the fact.
That's the only plugin.
So build a plugin, though, mechanism for Argo, and don't make Argo such a core dependency of the platform. Make an abstraction, build the plugin for Argo, and then if the Flux community decide they want to build one, if the Carvel Cap Controller guys decide they want to build one, if the Rancher Fleet guys decide that they want to build one, great. If the guy who wants to run kubectl apply from a GitHub Actions wants to build one that meets the contract, great. Done.
Exactly. I mean, that's what you're saying now is essentially you are repeating one of the core premises of Kubernetes, kind of like we did not build deployment pods and stateful set pods. They're all working independently. You can deploy a pod alone, or you can deploy it to replica set or stateful set. Right.
That's how Cluster API works. That's how all of the good projects in the CNCF work. That's how Crossplane works with MRs, right? Build a provider that meets the contract. Have a nice day.
Yeah. And I mean, in a way, also, especially now with V2, that's how compositions work. Hey, compositions work great with MRs. You don't want to use MRs? Well, or not exclusively.
Fine,
well, go for it.
Right, exactly. You just need to let us know when you're ready. Exactly.
Okay, now from another one. Actually, first, Akiva, thank you so much. Thanks so much, man. This is amazing. Big thumbs up. Ask a question. We have a requirement to stop all dev pods in Kubernetes every night. How would you recommend doing it? First of all, I feel that the question might be wrong. Let me answer first, then I'll let you, Scott, speak to this question and then rephrase the question, right? The answer to this question could be you just have a process that basically scales all your deployments, stateful set what's or not to zero. Right? It's relatively easy. I'm not sure, probably there is a tool that will do that. But even if there isn't, you can have a cron job that does that. It's relatively straightforward, right? Just scale everything to zero. Now,
unless it's managed through Argo. And then you have to pause the applications. So you gotta mention Argo.
Then you have a GitHub Actions that actually modifies all manifests in Git. Or you exclude replicas from Argo CD, and then you can go to the first solution. But let me give a potentially different question to that. How do we sound to zero if our pods are not in use? Because that would have the same.
Or Knative.
Exactly. But what I'm trying to say with this is kind of like, to me, that's really, you want to scale to zero in depth because you want to save on costs, and that makes perfect sense. But then why at night, right? Why not simply, okay, so nobody's using this thing for 15 minutes, let's scale it down.
Exactly.
That would be,
scale it down in the middle of the day.
Knative, what's not.
Exactly. Keda is great at that. Knative is great. If you're using Knative, it's awesome. Keda, the benefit of it is that you don't need to change your manifests. You just add another manifest. Knative is a great approach that just builds that in from the get-go. But it does require a change to the manifest that you're supplying, right? So there's trade-offs.
Knative is a bit problematic in my eyes because if you want only in one environment but not in production, then having Knative in dev, but something completely different in production might be problematic. That's where Keda would be.
Why not use Knative in production and just turn off scale to zero, which is a global cluster setting? Oh,
yeah. But let's say that for some reason you want only in development. You don't want to use Knative in elsewhere. Then Keda sounds like a better solution because you just put it on top of what you already have, right? Wherever you want it.
Yeah. In general, the only thing that I would add there is that there are other tools that exist out there that help in this as well. Things like ScaleOps that does have like scheduled policies for when to scale things down and when not to. And like there's a bunch of tools out there that do this. But I think that what Victor was saying is really important, which is We should be scaling down when it's not being used, not based off of set times. Now, one of the things that I actually just led the CNCF Jerusalem meetup out here in Israel the other day. And one of the sessions the session that I gave was on integrating Keda together with Cluster API. And Keda can also scale Cluster API clusters, and it can do cluster auto scaling, unknown trick that people don't know. But there, one of the use cases I had is there is a cron scaler in Keda. So you can have during this hour, scale it down to 0 replicas. During this time, scale it up to 3, right? Do whatever. So you can do that with Keda very easily on a cron. So even that use case, never use a cron job, just use Keda and use the cron scaler and say, at this time, scale down, at this time, scale up. Have a nice day.
You know, this reminds me a lot of my days when I was doing consulting, as one of the things I was fighting over is that I would very often get a solution formulated as a question. And this is how this feels to me, right? This is kind of, oh, somebody wants to scale down when it's not used because, and then what would be the solution? The solution should be to scale down at night because we are not using it at night. But then you're actually already modifying the question so much that you might easily skip the right solution.
That's why. Have you ever seen the xyproblem.info? It's exactly
no.
that. It's one of the greater websites that exists. I just sent it to you in the private chat. But it's the xyproblem.info is exactly what you were just mentioning. I use this all the time where, hi, how do I get the last two letters? Like, how do I get the last two letters of, the file name? Why? 30 questions later, well, I want to get the file name. I want to get the file extension. Yeah, well,
extension,
docx
exactly.
Is 4, doc is 3, targz, which one is it? GZ or targz? Well, like, what's the actual thing that we're asking for here instead of the pre-processed question?
Exactly. Oh, now, before I forget, if I ever find it, we have a word from our sponsor, from Codefresh, sponsoring this stream. Thank you, Codefresh, for so much. So what they give you, the reason why we are doing all this is that if you're into GitOps, specifically Argo CD, and you want to learn more about it, you want to be certified, you want to go through basic training, to some middle range training, to some very advanced training, this is the place. You go to learning.codefresh.io, you type code Victor with K. I heard that there is at least one case where people tried code Victor with C and didn't work. So, and you get 50% off. So go and do it. Bunch of good stuff. I know the author of the most of it. Amazing guy. Blind trust into his capabilities. It must be awesome. Go and try it out. Thank you, Codefresh, for sponsoring this. Now let's go back to the questions. Oh, I see new questions while I was saying this. Cool. Will AI replace DevOps and cloud engineer? And in which time approx? Let me put it this way. I don't see at any reasonable time frame AI replacing engineers, software engineers. I'm intentionally saying software engineer because you might easily change the title 7 times in the next 3 years, kind of like. I don't like, will it replace cloud engineer and stuff like that? That's very specific. You might change the role. It will not replace engineers. What I'm 100% convinced is that, and I don't know yet how, that AI will change the way how we work. And that's already happening in certain areas. Right now, pure application developers are more affected than anybody else, and it's already clear that's becoming very different. Now, whether you're still called application developer or the name is something else, to be honest, but it is changing, and it will change. It will probably change drastically, and I have only suspicions. So I don't really know how that will look like. I don't think that anybody does. Because if you asked me the same question a year ago, I would give you a very different answer than today. And I'm pretty sure that I will give a very different answer next year. It's changing very fast. But
And the one
ignoring
thing
it,
that I would
kind of
add
like,
on that-
okay, go for it.
the only thing that I would say is AI will not take away your job. An engineer not using AI will take away the job of an engineer not using AI, though. Meaning that
Yeah.
AI is going to be a tool that is used, and if you don't use it, you will be taken out, not by AI, but from those that use AI. Simply because what is going to happen is it's just like a manufacturing plant before the Industrial Revolution was able to produce X. And the Industrial Revolution comes, and now they're able to produce 10 or 100X. Now, that didn't, in the long term, that didn't get rid of jobs. What that meant is that we were just producing 100X, right? And so you were moving at a much faster speed. The same thing happens here. In AI, AI is not going to take away the jobs of software engineers. It is just going to make what is demanded or expected from a software engineer to be so much higher that if you're not using AI, you will not be able to actually meet the bar that the industry is demanding from you. And therefore, engineers that use AI will take your job, but not AI itself. So use AI responsibly. Use AI.
I will say something potentially offensive, and that's that the real job of software engineers, and this is now before AI, right? Nothing to do with AI. The real job of software engineers is not to type on keyboard. That's not the primary function you have. Your primary function is to figure out what the problem is, to figure out how to solve it, to figure out how to design it. It's thinking, right? If all you do is write code exactly how somebody told you, without understanding what you're doing, why you're doing, how you're doing, why this works better than that, then you're in danger. If you're just a typist, if you just type. To me, that would be equivalent to kind of, hey, you call yourself book author, but actually you just type on a computer manuscript sent to you by Stephen King on a paper, kind of like, no, that's not your job. It never was. That's just a chore. I know this is radical, but to me, writing code is a chore, something that has to be done, but it's not my primary job. Or the same thing goes for executing command, just to be clear. Kind of like me being able to execute kube control get pods is not my primary job. And knowing that I should execute kube control get pods in specific situation, that's my job.
Okay.
I see you're unhappy with that answer, Scott.
No, I'm not sure. I'm not sure that I agree, but I'm not sure that I don't agree either. I have to think about it more. I have to process that.
Just to be clear, I'm not saying
it's
that's
a very
not
radical thought, which is all that I would say. I have to think.
To be clear, I'm not. That does not necessarily mean that we don't spend 90% of our work typing. I'm just saying that that's not the main and biggest value. Kind of like knowing why to use Kubernetes instead of ECS, that's much more valuable than and being experienced with Kubernetes and knowing why to use this service mesh instead of that service mesh. That's the main value rather than executed helm install.
What I would say,
that's what I'm trying to say.
Right, your job is business value, and the tool that you use for that may be writing code. It may be running scripts. It may be talking to people. It may be building a design doc. It may be a million things. In the end, your job is to bring business value. That's the only job that you have as a software engineer. The tools that you have for that are writing code, running things, building designs, building whatever it is. That is implementation detail of your actual goal, which is to bring business value.
100%. Okay, what are your thoughts on writing custom CRDs to replace Helm from internal for internal apps, be it with Crossplane or CRO? Is there a way to handle application dependencies for microservices? My thoughts are big, massive, like this huge. Yes. I strongly believe that. I do believe that CRDs is the Kubernetes native way to define what something is And we are already doing that, right? Just as you're not applying pods directly, you're using higher level abstraction, which is replica set, but then you say not even that, deployment that actually encapsulates something more meaningful. That's what we do with CRDs when whatever is baked into Kubernetes is not enough. And I can easily say that much of what is baked in Kubernetes is more like a blueprint than what you should use directly.
I completely agree. I also agree with the rather not that was mentioned there about Crow.
I was trying to be nice.
Although, hold on, I'm about to be nice here. 22 hours ago or so, there was the release of 0.40 of Crow. I still follow the project. And actually, a lot of the issues that you mentioned, Victor, in the initial video that you did on Crow have been solved now in 0.40. So 3 versions later.
Amazing.
But they finally solved the issue of nested default values, where like you had to mention if you had ingress and by default it was enabled false, but you had to actually like still include ingress in your resource. So like they've solved a lot of those issues. Unfortunately, I do think that they are falling into the pitfall that Crossplane fell into with patch and transform, where their schema is getting complex now because they've added in all these features to fix all these things, and these features make it so much more complex. But whatever it is, even Crow is better than Helm. Anything is better than Helm. Writing the raw YAML manifest on your own is better than Helm. Okay?
For your
Writing
apps.
the JSON format in protobufs and sending them over the wire to etcd directly is better than Helm.
We agree on that 100%. My biggest beef with Crow is that I think that YAML is a dead end, and I think it will become abomination, and eventually it will have to. I'm talking about YAML for Crow because there is a fundamental difference between me writing YAML as expressing what I want, and me writing YAML that is actually application that contains some logic and does something and so on and so forth. I'm not going to even discussion what it should be. Pick any language you want. But basically Crow is a controller. Controllers are written in code for a reason. And that reason is because they have logic that they need to implement. Oh, now they do this, then do that. And ignore this, skip this, loop through this, and so on and so forth. It needs to be something else than YAML. And definitely not Helm templates. If somebody suggested Crow should switch to Helm templates from YAML, then that would be even worse. From Ari, if you needed to roll out a new observability monitoring problem across a large number of clusters and want a single pane of glass, but Datadog paid solution not an option, how would you solve it? I know your answer. Your answer would be, oh, my brain stopped now. What's the tool you all? eBPF1.
So Pixie is a part of it, but Pixie is not the whole thing, right? Pixie, I think, is definitely a part of it from an open source side. It really depends on where you're running and things like that. There's a great way of using, like, if you can use cloud services and things like that, but the things like Datadog and Splunk and whatever are too expensive. We actually built a solution around ADX if you're running in Azure or anywhere else that works really well, like as a backend, and then you use Graphana as a front end above that in Hotel, and it works really well. You can use OpenObserve. I'm hearing really good things about OpenObserve. I don't have much experience with it yet, but it's pretty impressive from a self-deployable platform that also does have a commercial offering if you wanted to, but OpenObserve is pretty awesome. I think it's a GPL license, so it's just a question of if you have an issue with licensing and things like that. But then again, so is Grafana, and there's no option other than Grafana, really. So like you're stuck with a GPL in the monitoring space.
And you know, if we focus only on the single pane part of the question, kind of that's Grafana. Whatever is behind that,
or OpenObserve.
Or OpenObserve.
OpenObserve is the only.
I don't have much experience with it though, but yeah.
It's gaining a lot of traction, I will say, and it's the only thing that I would look at as an alternative. But Grafana, I think, is the best today that exists. And by the way, I do not like the format of Grafana dashboards. Writing them is a pain in the behind. But
Horrible.
it is the de facto
Nobody
standard.
ever.
Right.
No, I don't think that there is a person on planet that, and that's something I would really love. To be able to write dashboards myself, I don't think that there is a person that ever did it in Grafana. Such a person doesn't exist.
Right.
Exporting
really
your
hard.
dashboards, yes.
Yeah.
But even if you export and want to make a single change, I will still go to Grafana UI.
Exactly. I always write them in the UI, export them, and then put them into the Grafana operator to apply them back.
Yeah.
Exactly. But yes, Grafana is like Helm. It is, I do not like it, but there is no alternative to it because every third party in the world integrates with it, right? Like everything has a plugin to Grafana. I mean, if something is going to expose a dashboard, it's going to have a Grafana dashboard. It may have a Datadog dashboard. It may have a Spunk dashboard. It may have a this, but it's first of all going to have a Grafana one.
I would say that what Grafana for visualizing data is equivalent to Backstage. You like it, you don't like it, that's basically where everybody goes. That's everybody integrates with and so on and so forth.
Yeah.
Okay, hi friends. Oh, this is for you, Scott. Hi friends, I would like to try Cluster API by provisioning a cloud cluster in AWS and GCP from my home lab. Docs feel overwhelming. Any tips? Is the Cluster API book a must initially? All you, Scott.
The quick start page on Cluster API. The Cluster API book can be very overwhelming. There is the quick start guide there that is very much just a tutorial of next, and you can get it running. Again, anything that you are dealing with that deals with the cloud is going to be complex from the initial setup perspective in the sense of how do you authenticate to the cloud? If it's running in AWS, you're going to use workload identity. But what are you going to use? Are you going to use workload? Are you going to use IRSA? Or are you going to use pod identity? So you need to support both because not everyone has moved to pod identity. And okay, but if you're running on-prem, are you going to use STS or are you going to use just static access key secret key? And well, EKS Anywhere also added support, so then there's also support for IAM roles anywhere. And so the amount of options for authenticating to these cloud providers is numerous, and that's where some of the complexities can come. My general recommendation when it comes to Cluster API is start with CapD, which is Cluster API Provider Dev. It used to be Cluster API Provider Docker, but it's called Dev now because I think it also works with Podman. And whatever, but start with CapD, deploy it locally on your machine, get started, understand the mechanisms of Cluster API. From there, move to a cloud provider and all of that. But don't try to learn the integration with the cloud together with learning the concepts of Cluster API. Start locally on your machine. The quick start is great with that. You can just select which cloud provider in each of the boxes. And then once you've learned it with CapD, which you need no credentials, it just runs locally, then go to the AWS quick start and do it from there. There is a Cluster API AWS book itself. If you go to Cluster API Provider AWS, you'll get to their book, which has specific guides for AWS. Same thing goes for Azure, same thing for vSphere, same thing for Google, and so on and so forth.
What is the best way to run all dependencies in a dev environment and stay organized as a team? Is that GitOps, Scott? Or a script?
So
I mean,
it's
I'm
a real
assuming that I will assume just for a second that
GitOps.
But I would assume that. So my logic is that whatever the solution is to questions like this, I want to deviate as little from production and to do as little as possible.
Yes.
So my answer would be a question. How do you do it in production today?
Well, so yes and no. Yes and no to that one.
Does not mean that the answer is do the same.
Right.
It's the full question
right.
first.
Right. In general, when it comes to dev environments, it really comes down to, have you built microservices like 2% of the industry, or have you built distributed monoliths like 98% of the industry? And that's where the question is going to come down. Because if you have actually built microservices in the sense that you do not need to deploy all 50 microservices of your application in order to get it running in a dev environment, and you can actually just spin up your 1 and maybe 2 dependencies because you want to test the interaction between them, and maybe a database and a message queue or whatever, then I think that it's easy. In a tilt file, in Scaffold, although that's basically dead. Google killed that project. But you could use Tilt. You could
surprise.
Use Octedo. What?
I'm so surprised. Google killed the project?
I know. It's just
that
like
never happens.
They killed Canico and Scaffold on the same day. It was a lovely day for the Kubernetes community. But in general, like, I think Octedo, Tilt, things like that work great for simple use cases. When it comes to the really complex distributed monoliths, which unfortunately is the majority of applications that call themselves microservices, are not. And they end up having these weird dependency graphs between every single component. And this depends on this, which depends on these 3 things, which this depends. And it's cyclical dependencies and this, and there's no way to deploy from scratch because you have to have this old version that it's dependent on in order to deploy the new version. Yeah. And all of those use cases, that's where I say static staging environments, as much as I hate it, I just don't see it as viable. It's reality of the world. And that's why I think that tools like Octedo and whatever, as great as they are, one of the reasons I think that they haven't caught on as much as we as an industry thought that they would, is because, unfortunately, most companies simply are not following microservice practices. And because of that, these tools aren't able to work well, because Octedo is not going to be good if you need to deploy 100 microservices.
Exactly.
Together.
And I mean,
in one environment.
The reason why...
And that's nothing about Octedo.
And when you say not following best practices, sometimes the reason is simply you don't know what something really is, in this case, microservice. But very often it's simply the path of least resistance, because I already have this thingy that somehow works, and then it's the easiest for me to add that feature to that thingy, right? Instead of re-architecting it for that specific feature. And it's simply more work on a short run.
Exactly. Oh. And when we think that a lot of applications are still rewrites from monoliths that have been advanced since, and in those cases, it's much easier just to change things from talking over localhost to talking over an actual IP address and going over the network than it is to actually completely turn it into an event-driven application in a distributed system. And because of that, almost all monoliths that get broken down end up being broken down into distributed monoliths and not into actual microservice applications. Or they get rewritten as microservice-based applications, but they don't get upgraded to microservice applications or evolved into.
I think that this is basically we answered it. So I'm going to read only the last. Does Cluster API do a good job replacing Terraform?
So there's actually one important note here, which is GKE. Right. So there's only one important question here, which is specifically GKE. I have not been following Cluster API provider Google for a little while. It was having some challenges initially, and then I know that it started to pick up again just in terms of vendor support. Google was not really doing much. AWS and Azure and VMware were doing a lot, and therefore those providers are great. Google, I know that was having a bit of struggle, and then some other companies came in. People from Spectro, people from D2IQ, people from different vendors came in and really helped out with bringing back up GCP. When I stopped really dealing with CapG, which is cluster API provider Google, was like just after they added the GKE support. And I know it was minimal, but from the little bit that I've been following, I know that it has gotten better. I can tell you that I know products that I trust very much in the Kubernetes space that use cluster API provider Google for GKE clusters, meaning it is there, the features are there. I just don't have the personal experience to be able to like give it like my stamp of yes, like I think that it's great because I haven't tested it with that. Do I think the cluster API is better than Terraform for like COPS, let's say, for managing Kubernetes clusters? The answer is yes, and I'm sorry, Justin. You built an awesome project and maintained an awesome project, but I'm a cluster API guy. So yes, but the two do not contradict one another. If you use Terraform for a bunch of things, you can use the Kubernetes provider. If you want to use Terraform, that doesn't mean you can't use cluster API because you can use the Kubernetes provider to provision the cluster resource of cluster API instead of talking to the Google API directly. And I think that that is better also than something like COPS because, again, you're just building a different interface above the better backend. And I think the better backend is always going to be Kubernetes with consistent reconciliation. And you want to build an interface above that that's a Helm chart, or that's your own wrapper cross-plane composition, or that's a Terraform module, or that's a Backstage software template, or whatever it is, go right ahead. That's up to you to do. But that's the user interface, not the implementation. Implementation, cluster API.
And you know, it's not only better because of Kubernetes alone, it's also better because of the ecosystem, right? Like previously we talked about GitOps, kind of like, just do it. And like there are so many really beneficial things in the ecosystem that apply to almost anything, including if you use some Kubernetes native like cluster API to manage resources outside of the cluster. Just do it. We can scale consumer pods from 0 replicas based on a number of messages in the queue. How would you recommend scaling the front-end and back-end pods so that developers aren't confused? Is that the previous answer, Scott? Keda? Just use Keda.
Yeah, this would be Keda.
Yeah.
Why would they be confused? It would just load slowly. Meaning when the request comes in, there's the HTTP scaler in Keda that basically when a request comes in, it's going to queue that message. The pod is going to start up and the front end comes up. And same thing for the back end. If it's HTTP APIs, if it's whatever, same thing goes.
And yeah, I mean, there is not much to be confused. And it's not going to be slower because when it takes time to bring up new replicas, that's still going to be ultimately faster not bringing them at all.
Well, no, I was going to say, no, but it is going to be slower. If you always had one replica, when they go to the website, it is going to load automatically. When it is zero,
that's true. If it's zero,
the
yes.
startup time of the pod is going to be higher. And that is where there is one thing that I think is not used enough in the industry that I think is extremely beneficial, which are like node image fetcher daemon sets, where basically you have a daemon set on all of your nodes that goes and actually does like a CRI CTL pull and basically just pulls the image into containerd so that when a pod goes to start up, it doesn't need to pull down the image. And the way that I do it is any images that are user facing or that are critical, I think should be put into a config map that's watched by that daemon set, and that it goes and pulls those images down onto the nodes. And the reason is because it will just make any time, because you don't know, the pod is going to come up now on a different node than it was on before, and the image isn't there. Again, if it's a distroless image with a tiny Go binary, it doesn't matter. But the truth of the matter is that most applications aren't that way, and most front ends aren't that way. Most front ends are written in JavaScript, and JavaScript is going to have NPM modules that weigh 1.5 gigs, because welcome to NPM modules. And to pull that is not going to be fun. And a lot of images are still based off of Ubuntu. right? And so, and I'm not saying that those are good things necessarily in how we should be doing things. We should be using slimmer images and all of that, but I'm just talking reality checks here. And therefore, node fetch daemon sets are a huge benefit in those use cases because it will make the startup time that much shorter, which will make it so that the effect on your end user is as limited as possible with scale to zero.
Okay. How do we become good Kubernetes engineers? Or when faced with uncertainty due to new technology, should we learn it or no? I'm going to answer the second question first because I think that it provides the answer to the first one as well. And that answer is that all new technologies are always built on top of previous experiences, previous technologies, right? Even AI, I dare you to kind of like do something with AI and say, I know nothing about anything else. Now, I know nothing about Kubernetes, I'm going to use AI or coding or stuff like that. It's always built on top of something we had before, conceptually, technically, layering, whatever. And that means that when faced learning, let's say Kubernetes now, and let's say that for whatever imaginary reason, which is not true, is going away, which is not true, just to be clear, still, whatever will replace Kubernetes one day will be based partly on the principles and technology and what's not of Kubernetes, just as Kubernetes is based on what we had before. So learning something is never a waste. Now, whether you can, if you learn X instead of Y, was your time 10% better spent? Yeah, we can enter the discussion. But it's never a waste. Never a waste, right? I don't think that there is a single thing that I learned in my life. This is complete waste. Related to software, just to be clear. And I feel that that answered the first question, because how do you become good Kubernetes engineer? By not only learning Kubernetes, but also by learning what was there before. You should know Linux. You should understand containers. You should understand networking. You should understand storage, and so on and so forth, right? Now, should you spend 3 years learning networking? I'm not saying that, just to be clear. You can have a relatively superficial knowledge of certain lower level details, but you need to know them. So it's not a waste.
What I would say is I agree, and I just want to expand on that for 1 second, which is, when I have a major issue with a lot of what we're seeing today in the DevOps world, which is that people are going straight from nothing to, I want to be a DevOps engineer. So now, and let's not get into the debate of the fact there should be no such term DevOps engineer, but that's a whole nother story. But people that write CI/CD, that do Kubernetes, that do all those things, if you don't know what it is you are orchestrating, in Kubernetes, you are orchestrating containers, which in the end are creating user namespaces within pods and running processes within Linux and creating all of these different elements within the Linux kernel that are running, within user space that are running. We're not going to get into the whole way of how containers run. But basically, if you don't understand that, if you don't understand what you're orchestrating, then you're never going to be actually good at that high level object. You have to understand what it is that you are doing. Meaning, when we look at like the initial, like at the older generation of DevOps engineers, of Kubernetes engineers, when you talk to Kubernetes like engineers that are more senior in this, 99% of them started as sysadmins. And they were Linux admins, and they had Linux at home, or they were this, and they were the geeks that dealt with Linux on a daily basis and knew all this stuff. So when they came to Kubernetes, it was simply making their lives easier, and it was orchestrating the things that they already knew. And therefore, they were really good at it because all of the abstractions were built above the things that they already knew. But the same issue, by the way, you could take to cloud. When we dealt with on-prem, when everyone was on-prem, engineers knew infrastructure. You get to the cloud, you don't know what a server is. It's an operating system. What's a server? I've never seen a server. I don't know what a server is, because you don't deal with hardware. You don't deal with these things. Now, I think that it dumbs us down as an industry, and it dumbs down the engineers, which, again, I'm not saying that you need to have the same level of expertise and understand how the Linux kernel works and what a user, and necessarily, you need to know there is such thing as a namespace before Kubernetes. Let's put it at that.
Yep.
You need to understand that containerd does not run your container and that CTR does, right? Like, you need to understand the different things of what a container runtime is and what the different levels are. Now, do you actually have to look at the code and understand how the code runs and what the difference between different types of processes are and what the difference between C groups V1 and C groups V2 is? No. But you need to understand those key points. The other thing to make you a good Kubernetes engineer is the other side. You are never a good engineer if you don't understand your consumer. Meaning, write an application, build a container image from it, and deploy it. Write the manifests, deploy it to Kubernetes, create a new version, do an upgrade of it, add a database, expose it via ingress. Everything that you are exposing to your users, you go and do their job for a day. You go and build an application, test it out, see these things. Because if you do not understand the consumer, you are never going to build a good abstraction, and you are never going to build a good platform and understand what you need to be looking at. Because you have to understand all perspectives. To be a good Kubernetes engineer means that when the user comes to you with an issue, you know what he's thinking. You have to put yourself in his mental model for a second, understand that, convert it now to your mental model who know Kubernetes better, then start debugging. And through the knowledge that you built in that first part that I was saying, by understanding core basics of Linux, of all of that, you're then able to debug. So you have to learn both sides, not just Kubernetes.
Basically, the latter part of that talk you just gave, basically that's why significant number of platforms truly fail, right? Internal platforms. Kind of like this thing, right? Because, oh, I need it. No, you don't. No, actually, you need it. Nobody gives a rat's ass about what you need. You're serving somebody, you're serving a customer. And if you have no idea what the customer needs, you're toast. And the only way how to know what customer needs is two things. First of all, to do what customer does. You know, that would be like, you know, I design Amazon.com and I'm not a Prime member. I never ordered a package in my life. Come on.
Right.
Yeah. Okay. Thoughts on how nootropic weekly limits? Isn't it insane that you have to think hold yourself back when paying $200 a month, 25 to 35 times per week? Okay, so I'm not deep into it. I just superficially followed it, so I might be wrong. The research into nootropic limitations affects very small percentage of people, first of all.
Yes.
And significant number of people affected are people who go crazy. I mean, crazy in a positive way. Hey, actually, I work with one agent at a time. There are people who spin up like 50 agents, right, in parallel, that are all consuming APIs and doing 50 different things in parallel and what's not. Kind of having to pay more for that is not a problem. Not a problem. If I'm spinning up infinite number of parallel processes using AI, then power to you. Kind of like, you're doing great. You're doing amazing. Kind of like, it will not make a much difference whether you pay $200 or $500 a month. The comment about Opus, 25 to 35 Opus time per week. First of all, that amount of time is close to the full work week. Kind of like, so officially, I mean, I know that most of us work more, but you work 40 hours a week, right? So that's so close to that time of, and more importantly, it's about knowing what to use and when. I don't use Opus much, to be honest. Kind of, it's simply, there are no tangible benefits using Opus most of. Kind of when I write code, I might use Opus, for example, initially brainstorming, hey, take a look at the existing code. This is my idea that I want to do for the new feature. Let's think about it. Let's brainstorm it. Let's create a very detailed PRD. Yes, right? I do that. And then Sonnet. Sonnet is just it's just as good as Opus for a significant number of tasks. So
it's even better.
I don't see that.
Quick.
And it's quicker. I almost forgot that, actually. So it's better, actually. All the same results, much quicker, and you iterate fast. Actually, that speed is very important. So I don't see it as a big problem, to be honest. And I still think, I might be wrong on this, I think that still Anthropic pricing and limitations are still more generous than most others.
Yes.
And look, if you spend it more than that, you're probably getting much more value than those $200 in return.
Exactly. And I think that we also have to be fair here. And we have to understand that Cursor, they raised all their pricing and they made a complete shit show of, by the way, their whole thing there. Anthropic are being way more open and clear about these changes and whatever. And I think excuse me, in a good manner. So I actually respect them for that. And what we have to understand is that these companies were selling at a loss for such a long period in order to get the market share. They can't just keep losing all of this money. Inference is expensive. And as more and more people are using the service, as they're
it's getting cheaper, just to be clear. But
it is. And over time, I think AI services will become cheaper again. But currently, their running AI use cases, especially things like Opus, are extremely expensive to run. And because of that, I think that it is not fair to expect that what we were paying at the, let's say, initial pricing of something is what you're going to be paying a year later. I think that the weekly limits are completely fair. If there's something that I don't like is the 5-hour limits. I really wish that they made them a bit larger and made it into like 8-hour limits, because it's like an 8-hour working day. So I think that they should just be setting higher limits and say like, during your working day, because what I don't like is when like all of a sudden, because it's 5 hours at this, and let's say that I take a late lunch or something like that, and now all of a sudden, like at the 4th hour, it runs out, and now like, what do I do? And like, I wish that I had just like the work day. So if they did 8 or 10-hour sessions in terms of limits instead of 5, I think would be better. But that's my one complaint to Anthropic on that matter. Beyond that, I'm perfectly fine with their weekly limits.
Actually, a few days ago, I saw some statistics of how much people, kind of top spenders on Anthropic. And that's not top spenders how much they paid Anthropic, but how much actually
how much they
would have paid. Not necessarily cost, but if they were paying per pay tokens, not subscription, how much they. And there are hundreds of thousands of dollars, hundreds of thousands, in a month, right? It's power users, really, and if you're a power user, either you're doing something terribly wrong or you're getting much more value from it.
Right.
Okay, so what would you recommend using, say, together with Backstage? Oh. This is, and let me read actually. Custom actions and scaffolding pure manifest based. I think that, Scott, this is the moment when you explain your plugin.
Yes. So
because your plugin is basically doing what I was complaining before I found out your plugin. Kind of like your plugin reads most of my complaints about Backstage. Exactly. There were very few times I was so excited as when I saw your plugin.
So we built a set of plugins that are open source plugins. On a lot of them are on the Backstage marketplace as well. If you go to the Backstage.io/plugins, and the one that Victor is talking about is the Kubernetes ingester. It's called, and basically what we do is when you create XRDs in your cluster using Crossplane. We basically auto ingest those XRD APIs. So my recommendation is to build Crossplane XRDs and compositions. Those are automatically detected by Backstage, and software templates are auto-generated and registered into Backstage from the Kubernetes XRD. So we auto-generate the forms based off the OpenAPI schema. And then when you fill it out, you make your request. And the important thing is you get to a certain phase in the section there, and we actually ask you for the Git details. And the reason is that we never push it actually to Kubernetes. We read from Kubernetes to get data, but we always push to Git. So there's support for Bitbucket, GitLab, GitHub, all of the main ones. But basically, it creates a PR in Git. That gets merged, and Flux CD, if you're smart, or if you are part of the, cult of the masses and use Argo CD, you can use that as well, watches Git as well, and it will just pull those manifests down. And that's really the approach.
Wait. Stop.
Yeah.
Stop there. Are you saying that you created that is kind of GitOps based and doesn't work only with Flux?
Yes.
I'm now I'm trashing Cargo now.
Exactly.
That's what I'm doing.
Exactly. Oh, I completely understood that. Yes, we work with any GitOps tool, even if you chose the wrong one.
Doesn't matter.
Exactly, because it doesn't matter. I push it to Git. My interface is Git.
Exactly.
That's all I care about. And so really the idea is that you create your XRD and then it can be exposed. You want to do kubectl, go ahead. You want to push directly to Git, go right ahead. You want to use Backstage as UI, go right ahead. There's the Crossplane frontend plugin that we built that gives like visual graphs of your Crossplane resources and all of that. Thank you a lot to Christopher, I think is his name. I may be butchering that, but
Chris.
From Upbound as well, from the Crossplane guys, that actually contributed a much better UX around the graphs, because I am a horrible UX designer. And so he built a much better UI that we merged in recently. But yeah, it's really awesome. And it makes just the experience of, we also auto find any claims that you have in the cluster and register those as components without you needing to write catalog info YAMLs and put them into Git. So you basically get a self-maintained, updating Kubernetes-based Backstage entities without ever needing to write a single catalog info YAML in Git. Yeah, that's basically, those are like 3 of the 20-something plugins that we've released, but yeah.
I mean, it's simply conceptually what Backstage does without plugins to me doesn't make sense. Having to create, what's the name? Up manifest, or remind me?
The catalog info YAML?
Catalog
app
info.
config?
Kind of simply, app config. Simply kind of basically, if I use Kubernetes, that app config is 90% the same as the schema of Kubernetes API. And schema of Kubernetes API is based on OpenAPI. So guess what? It is actually conceptually the same as many other schemas. Basically, it's just copying and pasting and then modifying the same thing over and over again. And then you have a nightmare that, we're there, and then I need to go to 57 other places to change the same thing.
Exactly.
Say no.
Exactly.
It's a general rule, and this is as a general rule, not directly related to Backstage, right? We live in a world where everything is communicated through APIs. APIs are discoverable, right? Whomever needs to do something with API can discover what can be done with that API. Doesn't matter whether we're talking about Backstage or anything else. Kind of, if I need to rewrite the same thing over and over again because somebody forgot to put 50 lines of code that will discover what that API can do, then that's a bad solution. Whatever you're using.
Yeah.
Okay, we are almost done. What else? Let's do one more, or maybe 2. Fast. Okay, let's do fast one. Add network policies to Kubernetes cluster. Do you recommend Cilium? I mean, I don't think that
recommend
network.
use the CNI that you have. Recommend
Exactly.
the CNI that's in your cluster. If you are creating a new cluster, Cilium is a de facto standard. I personally like Antria, but if I'm in AWS, I like VPC CNI. If I'm in Google, I like Google's networking. If I'm in Azure, I like Azure's CNI, which is based off of Cilium, just like Google's is. Azure's AWS's isn't. But use whatever your distribution has. Anything except Flannel today has Kubernetes network policies.
Next one. I want to experiment with message queues in my home lab Kubernetes cluster between front and would you recommend Kafka or RabbitMQ and in which scenario? As I'm going to assume that this question is not I have because of the job to learn one of those, but I simply want to experiment with message queues. I recommend neither of those. Nuts. I recommend nuts. It's small. And I recommend it's fast. Really?
I like Rabbit. Yeah. I like Rabbi MQ.
Oh, I like
Rabbi MQ. Exactly.
Okay. No. There we go.
I do like Rabbit MQ though, personally. But yeah, if they use one of them at your company, learn that one. Otherwise, learn Nats, Kafka, Rabbit. Doesn't matter. Just learn something in the event and message queuing so that you can understand the ideas. In the end, you can switch between the two. Once you know one, you can understand the other. Yes, Kafka and Rabbit are a bit different, but in theory,
conceptually they're the same. That's syntax. Different syntax more than anything.
It is.
I mean, there are of course always differences, but the question is whether you understand how queues work.
In theory, you understand it, then you can use the others as well. Yeah.
Okay. Okay. Last one. No, I think that we already answered.
That one we already did. Yeah.
Exactly. I think what I like about Cilium is network policy logging. Let's do one more. What is the best path for an experienced DevOps engineer to transition into AI/ML engineer role? How can I best position myself, and what are my options? MLOps. I mean, I don't like the term MLOps. Let's start with that. From the operational perspective, I don't think that there is much difference. I mean, there are, of course, some differences. Like, if you're going to run inference, you need to deal with GPUs instead of CPUs or on top of CPUs. But essentially, it's not really a big difference. The difference is that if you go into data science, that's very, very, very different, right? But from operational perspective, I'm not saying it's the same, right? Kind of this sounds like what I said about RabbitMQ and what was the other one? Kafka. There are differences, but not that big. Conceptually, it's all the same. Operational perspective.
Here, right. In terms of the best path from my perspective is do the DevOps of. I can't believe I'm using that term, but I'm becoming subjected to the industry's terms. Do the DevOps of AI and ML. Okay, so do the deployments of those things into Kubernetes, of AI runtimes, of whatever. Build CI/CD pipelines around XYZ. Do these things. And because once you do that, when you go to the other side, you will understand another interface into it. So if you're coming from the DevOps side, great. Learn the DevOps angle of AI. And then when you go to the AI side, you'll understand it already from one perspective. Then it's just learning another perspective of something that you've already learned, right? I always say learn it from your perspective first and then go over. Don't go and learn the thing directly. Learn it from your perspective and then go over to the thing and actually learn it from the core, because you'll at least have some recognition and it'll be easier for you. And you can do that in your current position without needing to jump around and get completely lost.
Yeah, I mean, to me, that's a lifelong philosophy, what you just said, that whenever I was changing what I do, I always changed it by still being close to what I was doing before. Eventually, over time, I'm doing now very, very different things than I was doing 15 years ago, right? But I always try to make those changes close to my current experience. Like now I'm very much interested into AI. guess around what kind of not around marketing, right? Or around I don't know, accounting. I'm very much interested in AI from the ops perspective, right? Just it's so much easier for me to actually, when I move into something new, that something new is always split into many different areas, and I pick the area where I'm close, where I'm experienced.
Yeah.
I think that's it for today. Thank you everybody for coming. Yeah. See you next week. Cheers.
Cheers.